Welcome to the Greater New York Dental Meeting 2024. My name is Mohamed Abdel. I'm a lecturer in Infected Prosthodontic Department, Suez University, Egypt. Today, I'll be presenting scientific poster named Implant Prosthetic Design and Restorative Material Virtual Optimization using 3D Finite Element Analysis. As an introduction to this topic, many issues related to the excess load transferred to the implant, which affect the biomechanical behavior and long-term longevity. The objective and the goal of this study was to assess how distinct implant prosthetic design and material would affect the biomechanical behavior using 3D finite element analysis to optimally restore implant in the posterior edentulous area. Methods and materials. Various prosthetic implant designs was performed using a 3D modeling software, such as 3D Matic or SolidWorks, that simulated the maxillary and mandibular posterior edentulous area, and using 3D guiding and implant planning software to generate different prosthetic designs, starting from fixed bridge, medial cantilever, and distal cantilever, separate crowns, and utilizing different restorative material. After creating the 3D individualized models from different prosthetic configurations and different restorative material, we import these models into finite element analysis software, just like ANSYS or Markman, for instance, or Abacus software. And in this software, we will define the boundary conditions. We will do the meshing and selecting the most appropriate element and node configuration to properly interpolate and describe our structure. And then we will apply a 300 Newton load in an axial direct analysis. The von Mises stresses of all models in the prosthesis, implant, and even in the bone will be calculated, and we can have a stress map in the restoration and implant as shown here. These results can be tabulated and collected in a descriptive chart to have the different stresses and von Mises stresses generated at prosthesis, implant, and bone for every and different designs. As a conclusion here, the following conclusion were drawn within the constraints of this study and the limitation of this study. The first conclusion is fixed design should be preferable and should be selected as a favorable prosthetic design when restoring multiple units. And the combination between BEC, which is a polymeric restorative material, and zirconia can be recommended instead of monolithic zirconia bridges to reduce the stress magnitude. The second conclusion is we should avoid distal cantilever because we have the highest von Mises stresses value were recorded in distal cantilever bridge using the monolithic zirconia. And the third and the last conclusion here, that even if you don't have enough bone and you don't have the time to generate and to regenerate the bony bases, so you can go for the medial cantilever design instead, or as a second alternative to the fixed design when restoring multiple implant in the posterior area. So thank you very much for your listening, and I hope I'm helpful and to have the chance to share ideas and share knowledge together. And I hope to see you soon. Thank you.